In the previous video for section 8b, we did problems related to exponential growth and doubling time. In this video, we'll do problems related to exponential decay and half-life. So we discussed the formulas that we use for exponential decay. If you recall, this is the formula for exponential decay related to half-life. So when a substance decays, it becomes half of itself, and recall that half-life is the time that it takes to become half, and T is the time at which we're interested in that particular quantity. So the question here is, the half-life is 400 years, so we know that is T half. So if you start with some amount, it doesn't matter what it is, a certain amount of substance, what fraction of it will remain in 120 years? So remember that if we need to find the fraction of what remains, then it's better to use this version of the formula. When you go new value over initial value, that gives us the fraction. And we get that by dividing both sides with the original formula with the initial value. So new value over the initial value is equal to half to the T over T half. Plug in the numbers. All we need to do is plug in the time at which we're interested in that particular fraction of what remains as compared to the initial value. This is your half-life, and this would give us half to the 0.3, and that is 0.81, which is about 81% of the substance will remain. So that's 81% of the initial quantity will remain after 120 years. So all we had to do is read the question carefully, recognize that it is an exponential decrease or decay, use the appropriate formulas, and figure out the fraction. Now, after 2,500 years, it's the same thing. Half-life is 400, so T half is 400, not 4,000. 400 years, and 2,500 is the time at which we are interested in that particular fraction of what remains. And when you simplify it, you get 0.013. A very tiny amount, about 1.3% of the substance remains after 120 years. Now, another problem, very similar to the one that we just did. Radium is another radioactive substance which decays. It becomes half of itself in 1,600 years. You start off with 1 kilogram of the substance. How much will remain after 1,000 years? So here we're not, or I think what we worked out here is for 10,000 years. So let's just do this for 10,000 years because it's the same formula. So the half-life of this radioactive substance is 1,600 years. The initial value is 1 kilogram. The time at which we're interested in figuring out the new value, we're not trying to figure out the fraction of what remains, we're trying to find out the quantity, the actual quantity that remains after 10,000 years. So the time at which we need to figure out this new quantity is 10,000 years. So this is the formula that we've been using for what fraction remains, but that is not what we're going to use now. We're going to use the initial formula, which says the new value, because we have to solve for that. That's what we're trying to figure out. What is the new value when the initial value is 1 kilogram and the half time or the half-life is 1,600 years, and we're trying to figure out how much remains, how much of that 1 kilogram remains in 10,000 years. So when we simplify it, the answer is 0.013 kilograms. So we start off with 1 kilogram of the substance. Time passes. How many years? 10,000 years pass, and what we are left with is about 0.013 kilograms. So another example of exponential decrease or decay. A cleanup project is reducing the concentration of pollutant. We're trying to reduce the concentration of pollutant in the water supply, and it reduces by a certain percent per week. Every week, it reduces by a fixed percent, which is 3.5%. What is the half-life of the concentration of the pollutant? So what fraction of the original amount of pollutant will remain when the project ends in 1 year? So first, we need to figure out the half-life. Remember the formula for half-life. T half is the same as T double, 70 over the percent. So that is 70 over 3.5 because it decreases by 3.5% every week. That's why your answer is in weeks. Your half-life is 20 weeks, which means that in 20 weeks, the pollutant is half of what it was when it started. So that is the half-life. Now the next question says, what fraction of the original amount of pollutant will remain when the project ends in 1 year, which is 52 weeks? When the question says what fraction of it remains, you have to go new value over old value equals 1/2 t over t half. We've seen this with exponential increase as well. Plug in all the numbers and you get 0.16. 0.16, which is a small fraction, 16 over 100, which is 16% of the quantity that you started with, that is the old amount, will remain in 52 weeks, which is 1 year.